Okay, to rewrite this so it's not in fractional form, what I'm going to do first is I'm going to multiply top and bottom by the conjugate. And when I do that, the conjugate basically is the same thing except you have opposite signs. So what I'm trying to get is a difference of squares. So I get 1 minus sine x over 1 minus sine x. And when I do that, on top I get 1 minus sine x over 1 minus sine x, or sine squared x. Now when I do that, this ends up being a Pythagorean identity, and 1 minus sine squared is equal to cosine squared. So I get 1 minus sine x over cosine squared x. Now what I'm going to do is I'm going to split this up into two fractions, because right now I'm still in a fraction. So when I do that, I get 1 over cosine squared x minus sine x over cosine squared x. Now, the 1 over cosine squared, I can take care of that right away, as that's going to become a secant squared x. But over here on the right, I have a sine x and a cosine squared, but if I split that up into two separate fractions by doing sine times, or I can make it, if I want, sine over cosine times 1 over cosine x, what that ends up giving me is now I can make the sine over cosine into a tangent, and 1 over cosine can now become a secant. Now, technically you're done because we're no longer in fraction form. If I were to factor out a secant, I just wanted to let you see what happens. If I were to do this, meaning we don't have to do it, but if I did, I would get secant x, and I would have a secant x minus a tangent x, and we have no identity for secant x minus tangent x, so there's really nothing I can do there. So that step is not necessary. And we are done.